All attendees are in listen-only mode.
Hi everybody, thanks for joining us today. We have a special guest speaker with us. Charlie Dunn is in project controls at Duke Energy. He has a lot of experience managing plant outages using 4D. My name is Sue Dengenis and I'm the Director of Marketing for Synchro Software. I apologize, I'm on the road so there might be a little bit of background noise today, but I'm just going to turn it right over to Charlie, let him get started. We encourage you to submit questions throughout the webinar and we will answer them at the end. So just type in the questions panel and I will get them and we'll get to them. So I'm going to turn it over to you, Charlie, and kick this off.
Okay, great. Thanks, Sue. So we got a brief session here. Appreciate anybody dialing in on a Friday. I'm going to take a little different tack than I normally do. I encourage those of you who haven't yet read it to take some time if you want to digest more about 4D, this article by Tom Sawyer. Since we'll have some time together today, I want to tell you a little bit about myself. Construction is creating something where once there was nothing. It goes back to what is great storytelling, because as people we all connect with great storytelling. And what is storytelling? Storytelling at its essence is imagining something that is not and taking other people there with you. So I appreciate that little clip. It's something that Synchro guys pulled out of some informal interview sessions. I'd much rather be out on a trail, and I'll probably, once we get off today, that's maybe where I'll head to see some of Blue Ridge. But we're looking at slides, so we deal with this as a format for communication. Got to put in a little plug. If you're on the West Coast for Airbnb, I had a great place at Oracle Open World a couple weeks ago where I was a 15-minute hike to this kind of view. This is my family photo. This little girl, when she was 4, talked me into letting her drive her tricycle across the Golden Gate Bridge and back on a beautiful night, so it wasn't too bad. We had the sun setting on the Pacific and a full moon rising over San Francisco. And I've come to realize that as a parent, we're never really cut out for a challenge like that, to see life start, grow, be challenged, struggle, and hopefully eventually flourish and be independent. We come into similar problems on projects, and I'll be talking about some challenges we've observed and learned from in outages. But for me, the simple parenting truth I've come to shoot for is this: I want to keep the twinkle in that little girl's eyes. Remember that. We'll talk about it briefly at the end of our time. There are a few things that I talk to every time I speak about project management or scheduling, and I don't apologize for that because I think to me these are very important principles. So what is scheduling? What is it we're talking about? We're scheduling an outage or scheduling a construction project. Well, there's a science. We define activities, network logic, so we can track progress, predict completion. We struggle with that predicting completion part of the science, but we'll leave that aside for now. But it's also, this is important, the art of communicating the schedule to stakeholders. We often forget about that, and because we forget about that, we fail by design. We have great computer tools for the science. Some might argue we have too many tools, but we struggle with tools for the art. And this is a problem because until we do the art well, there's a fundamental question that we can't answer. What does the schedule mean? That's important because data doesn't drive project success. People do. So today, I've been asked to talk about outages and how we've used 4D technology, and I decided to put it in a kind of a hats off to one of my favorite comedians, the top 10 lessons that I've learned in an outage. And what today is not going to be is trying to show you or convince you that you should use 4D. I'm kind of honestly growing tired of that conversation. The answer is yes. Wherever you are, jump on board, get going, and do it. So that's not the intent. What I'm trying to convey today is that I've come to realize there are some unique things that I've learned that I never would have learned had I not been in the crucible of an outage. So what is an outage? Well, talk about it this way. Similar to whitewater rafting, where you're trying to beat the river. And so this is me right here. This is the guy. We're trying to high side because the water pressure of the river going that way is trying to flip our boat. Well, we've got 1, 2, 3, 4, 5 tourists in the boat with us, and they're not high-siding together. They either didn't listen to the trip talk or weren't familiar or didn't have experience. So without their help in high-siding, the force and the pressure of the river takes over. And the flow of work through an outage can feel very much the same. So I can't take you and put you in the middle of an outage, but I can tell you often it can feel like this. So number 10, the top 10 list, the lesson I've learned, to overthrow the status quo is hard. Here's a saying, most of us can probably finish this. Build a better mousetrap and the world what? Will beat a path to your door? Well, you would think so, but I've observed this is not often the case. The first story is really something I saw before an outage, doing construction work. Most of us know about Ashford. They have hardeners for cement. Ashford had a scientist. He developed a better product for the final hardening phase of cement. What did Ashford do? They scratched their heads. They said, we don't think this is a good idea because we make so much money selling our hardener. So the scientist figured a way out of his contract, went and founded a startup company that became Synchro, which is a competing product to Ashford. And I watched on projects as it literally stunned us how much better this concrete hardener was. We could get that glass-like shine with the right kind of polishing a month after we started the cleaning process, whereas with Ashford's hardener, you'd work for a year, you wouldn't get the same level, and it had various other technical reasons why it was better. So that's just one of many examples of why the world won't always beat a path to your door. I came into outages, and again, an example that doesn't really involve 4D, I was told that the stations will be migrating from a tool called Artemis Project View, which in the 90s was state-of-the-art, and by 2012 was definitely showing its age, and met great resistance as I would use a tool called Primavera P6, which a lot of us would say was a global standard. Well, not where I was. So we observed this also in that, well, we've always done it this way. And in a public utility, you want to maintain these assets the same way for the lifetime of the utility. But when you have to do what my manager educated me, which is change a plane's engine while you're at 30,000 feet, you need the best technology and the latest tools to apply to that kind of effort. So I've learned that to overthrow the status quo is hard. This was my first outage project. We brought in a stator, it's £1 million. The first scheduling I did was to schedule taking this dirt down here. You see this line, we took the dirt down and rebuilt it back up because they determined that railway would collapse if we did not rebuild it. Here's the stator arriving. If you're starting to doze off on me, that horn blows for you. It really is impressive, the things that a huge organization that's maintaining assets that power millions of homes and businesses can do. And just the effort to coordinate bringing this from the construction or manufacturing site to our site was a massive project. And at the tail end of the stator is a job. This is a Schnabel car we just watched roll by, so the two ends of the car make up the car along with the load. The load becomes part of the car. So there's a Schnabel car boost, and that guy, the Schnabel car engineer, he's got a great job. He gets to travel around the country on rail, seeing some awesome stuff. So that number 10 lesson leads right into this number 9 lesson. Failure matters. We learn from experience. There's a Walt Disney quote. I've come to appreciate that we all need a good, hard failure. Now, I mentioned this to Tom DeGenis, and he sent me a quote from a politician that said, I've never failed, I've either learned or succeeded. Well, it came from a politician, so I'm going to call BS and say, no, we do fail. Let's tell the truth. But if we fail and learn, we can grow. First outage, when we brought that stator in, we had a baseline target of 36 days, we went 69 days. By financial metric, by scheduled performance metric, that was a failure. There's a Disney quote for you guys. Seen this kind of thing before. This is Las Vegas, the City Center project. That crane was the topic of debate when I was there in 2008. They didn't know how to demobilize the crane. They were worried it was going to cost them between a couple $100,000 to a couple million of unplanned dollars to demobilize the crane. Turns out they had a much bigger problem. Here you see the Heron Tower. These top 20 floors were the top real estate of this over, at that time, projected $11 billion, largest privately funded project in the history of the world. They had to stop the tower right here because not too long after I heard about this crane, they recognized that in these first floors they had not tied off rebar correctly. They would go to litigation, they would document over 3,600 construction defects. The owner of the company responsible for inspecting the rebar said this is a classic case of miscommunication. They didn't have a problem to immobilize a crane. What you see here is the concrete pad that now exists where once the Heron Tower stood. A $1 billion asset came to the ground, a significant failure. The project failed by a bigger metric. It killed 6 people, had 3 union work stoppages for safety concerns. Construction is an inherently dangerous and financially risky endeavor. But we have tools now and it doesn't need to be that way. The project I was on, we sold a 4D effort. We had 3 years of services in place, and the day after that proposal was signed, this announcement was made, August 1st, 2008, that Boyd was suspending work on the Echelon project. If you go to the strip today, the steel is still there. It still looks the same. We thought we had a failure fall of 2012, but the rigging device we used went to another site, and I stood next to these beams. They're about 2 feet taller than I am. I'm at 6'6". They're very wide, and those beams were in place in our facility and moved our first stator and our replacement. But the next facility, there's a calculation so that as the stator was rotated to lower into the turbine bay, it collapsed. It fell into what this is a switchgear room. Took both units offline. We reset our expectations spring of 2013 when we saw this. We recognized that by some metrics, yes, we failed, but by another, we succeeded. We completed the project safely. We were putting power on the grid. Again, the worst part of the failure is that this young man did not go home that night. 3 other individuals who I sat with in a safety orientation 2 weeks before our outage went to the hospital that night. These types of failures are not acceptable. And we have tools to have certainty, to get rid of risk, and create construction and maintenance, repair, and outage environments where we no longer have these kinds of stories at the end of projects. Number 8, people, then strategy, then tools. Now, I didn't technically first learn this in an outage, but I've seen it really kind of bubble to the surface. Here's a quote by John Wooden: "Players make plays. Plays don't make players." I've started to predict success first based on the team. Who's the implementation manager? Who's the project manager? Who are the supervisors? And no matter the tools we bring to bear, if the right players aren't in place, we're going to be in trouble. Number 7, segment the problem and eliminate noise. We tend to want to overgeneralize in some of our planning and our strategies. We need to segment and understand specifically what our challenges are, where there are overlaps, where there are opportunities to improve. This leads into number 6, define in order to optimize. I say stop hitting the marshmallow. We'll wail and wail at project challenges, but we've never defined to the right level of detail, and this is where I've seen 4D have a significant benefit, so that we can, for example, in this instance, understand every piece that we're taking off a motor and see with focus time. I call this focus time line just a little bit of magic, that way it auto filters to what's working concurrently. But until we are willing to do this level of definition, we can't optimize. We're only going to get status quo or worse. We are not going to see better performance. The other part of this story is this is a work product of a young civil engineer who'd been in our building for 6 months, had never seen this motor, did the modeling from 30-year-old drawings, pictures, and hanger sketches, and became the leader in a lean review where we used this model and what we call a script that you'll see come up next with some very simple but down to the literally minute details of how we utilize overhead polar crane, lay down areas, and bring in key components. I'll jump forward in this a little bit. And again, we took what had been an 8-activity schedule, turned it into approximately 90 activities. Those 8 activities were the smallest segment of an hour. We defined them down to 5 minutes. We understood every time we were moving anything and where we could, for example, consolidate more items, move them together. We've moved from 42 hours of best performance to 25 hours at best performance when we own the polar crane. And generally when we have the polar crane for this project, we're on outage critical path. We define an outage critical path hours having a value of $150,000 just for a ballpark number. So significant return on defining the problem so that we can optimize. Know your priorities. This kind of baffles me now that I see how intuitive it is, but how often we fail to do this. What is your priority of work and why? This is what critical path should show us, but either we don't believe critical path or we run into problems and we lose our brains. And anyway, I've seen it where teams are just running around escalating everything and making everything urgent, which simply means nothing is a priority. Congestion is only a problem if, and the answer to that is, you don't know your priorities. We'll have a congested workspace and, oh no, 2 to 3 guys or crews are supposed to be in there. What do we do? Well, that what do you do question should not be a question unless you don't understand your priorities. You work your priorities first, understand why, and then you continue on. And just for personal curiosity, we raised concerns during an outage in an online tool. And so I tracked day by day how many times for all the work going on in an outage, some 13,000 activities, 1,000 to 1,500, 1,600 extra employees on site, a significant volume of work. How many days during an outage would this congestion issue come up? And it was 100%. Every day I found an entry in that record where some crew tried to go to do work and there was congestion. And they had to go to this, do we know our priorities? Are they the right priorities? I'll circle back to that in a second with another one of our top 10. Number 4, don't work in the outage. Doesn't sound intuitive, but it's actually very intuitive. Manufacture, so work before the outage, build bigger assemblies and bring them in, and think. Set your priorities before the outage. Build your granular schedules before your outage. Anticipate your problems before your outage. And there's a subset to number 4 that we'll get to in the number 1 point, but don't work in the outage. Number 3, space matters. Let's get back to that congestion point. And here I just simply say blindness is a disease. If we are using tools that do not allow us to see space, we are blind. That is a disease. We will run into something. This is why I'm tired of the conversation, do we need to do 4D? Yes, it's not a question. Yes, we need to do 4D. Why? Because blindness is a disease. This was a simple tool we used, didn't get down to level 4 detail, but to show the moves we were going to do, and this is how we planned for the following outage when we moved the stator. We had a different type of crane. The previous crane allowed us to articulate out of the way, so it was built before the outage. And the reason we would articulate out of the way is we're going to pull the rotor out, which is right there, using a different crane, but in this outage we could not pull the rotor with the crane from a different vendor. So we had to build the crane on critical path. So we want to understand these red boxes you're seeing we're using to communicate for safety. No work would be performed in those red box areas when these lifts were going on. And as it came time to lift the 1,000,000-pound stator, you can imagine there was significant oversight, interest, input throughout the organization on how we would manage that. And this became our tool for managing that work. So space matters. Space for safety, space for coordination, space for efficiency. And here comes the trolley that will lift and work on the stator. And this became the most valuable asset for both our safety manager and the primary vendor safety manager. We would export 3D PDFs to show what the site coordination conditions would be at a given place and time. So simple, but clear. There was no misunderstanding. And we saw an additional value to this is that we could explain to the observers what the work would be, where the concerns were. They could raise additional concerns. And again, we were doing all of that explanation, not in the outage. We were working before the outage. Because often an observer will have a concern and they will stop work. And when you're stopping work on outage critical path, this is not good. Number 2, simple truth creates the greatest sense of urgency. So I'll talk about how do we create a sense of urgency in our teams. Well, sometimes I'll argue that we drive away the sense of urgency because we confuse everybody. The plans aren't clear. The Gantt charts are legible. The priorities aren't known. How do we solve that? Simple truth. And nothing creates simple truth for us, for an outage, better than 4D. Number 1, close the detail gap, and magic happens. What am I talking about with the detail gap? Well, I'm going to do a little drawing here. I've never done this before, so hopefully it's going to work well. So I've got an empty slide, and I've got a pen here. So I'm going to draw for you. So this is Eric. All right? Eric's coming to a scheduled meeting a year before our outage project. So this is at 1 year. Right? And here we've got 6 months out, and here we've got the milestone for our outage project. Now I'm leading the schedule meeting here, and we've got 3 big parts to any outage project. So that's our level 1. We're going to get tags, and we're going to take out the old stuff. And then level 2, we're going to bring in the new stuff. And number 3, we're going to assemble and test it, get it approved. So that's our level 1 3-part schedule. And then we get down here, we break it down to a little more detail. This is kind of what we can communicate to our management. And then we get way down here in the weeds. We're talking level 3 and level 4. Now that's a year out from the project. And right here, there's one piece of information. Eric's the only guy in the room who knows that information. And I've got a Gantt chart and some printouts and maybe some 2D drawings on the wall. Maybe we've even done some BIM modeling. Well, here's my challenge. Eric's line of sight right now is pretty wide. That's everything in his line of sight. And before this outage, he's got another outage project that's on his mind. So he's got all this on his mind. And then he's been renting a place, but he's trying to decide, is he going to buy a place, sell where his other place is, get rid of his per diem. So he's got to decide about a house. And like most of us, he's got a truck, and he's got a lease coming up on his truck. So he's been looking at, here I'm going to show myself for not being a great artist. But anyway, so he's got to decide, to get rid of his truck. And he's got a new relationship. So he's got this romantic engagement, and his first one didn't turn out so well, but trying to decide if second wife's a good idea. So that's on his mind, and then she's been pushing him for various reasons by this time. And then, he's got one daughter. She's going off to college, so he's got that that great thing to think about. But he's got the graduation, the money, and financing. So here's my question: a year out, what are the odds that Eric is going to identify this one critical item for me? And that is what I call the detail gap. Now, Eric, but I've got a mechanical guy here. He's my welder. And I've got a rigger here. And guess what? They all have their own line of sight issues getting to having a common understanding of this specific problem. So how do we close this detail gap? Well, what I propose and what I observe is that we get a time machine. It's called Synchro. We take our schedule, we take our model, we bring this project right here in front of these guys in such a compelling way that there is no detail gap. They see the work as it will happen a year from now. It consumes their imagination. They're able to speak a universal language. We close the detail gap and magic happens. And I've got proof. This project took us 4.5 weeks the first time around. We set a target to do it in 72 hours. The SME for our prime vendor who runs piping crews across the world said you couldn't do it. We're going to take the supply header over here, the return header, and the lead box, and all of those have to be out of the way so that we're clear to cut the lead box free and lift the stator off. we had this model built over a year out. We closed our detail gap. The scaffolding that's in place, the dance floor, so that we could work overhead and not stop work below. Every scaffolding sequence to support, and here on this legend off to the left, you see the things we do to communicate visually. And I'll often say, can your BI do this? There's no single business intelligence report or Gantt chart that's going to show you this kind of detail. And we had a schedule that actually showed every time we were turning a valve to drain it, every time we were cutting a pipe. And again, the end game is here, we've got to be able to cut free here to take this old stator out. And we went over this, we rehearsed it, we played with it, we experimented, we were aware of what our problems were. We worked with this lead box crew to actually understand everything they had to do in both the neutral and the mains to clear stuff, to break free, where we could store it. We had a clear, detailed understanding of everything in this schedule. So I mentioned the prime vendor. He said, with my A team, this is at least 7 days of work. And another guy is 30 years of the plan. He said, Charlie, this is not 72 hours of work. This is at least 12 days of work. Boy, we had a baseline the first time around. We came in, and prior to coming in, I had a couple other things in this detail gap. Guys get excited about this. I had one guy frustrated that I canceled our weekly review meeting, and I couldn't understand that because normally no one's upset about canceling a scheduling meeting. Well, it's because he wanted to see this, and the team wanted to see it. Now I talk about it. It's like I'd canceled recess. This was our opportunity to play, understand, close this detail gap, understand things. Well, night 2 of the outage, I met with the night shift supervisor. I said, hey, Bobby, how's it going? He said, Charlie, this is easy. We've got this. We've been here before. At that point, they were within 2 hours of on schedule. They were early on the supply header side. They were right on schedule on the return header side. They finished the supply header side 11 hours early. Out of 72, the return header was finished 1 hour early. Now, in an outage, you really do want to be right on schedule. You can create problems if you're not communicating well and you complete work early. And then these guys, the lead box also, they completed on schedule. So these guys were on time. And I'll quote the Genesis song in referring to this project often, that we came from the north, we came from the south with picks and with spades in a new kind of order, showing no fear of what lies up ahead. They'll never see the likes of us again. So we met that schedule, but we did something else. When we cut this lead box free in 2012, that was prior to being able to cut it, 26 hours of abatement. You can see my normally not great handwriting is made even worse by this tablet. So 26 hours of abatement to cut that lead box. Well, something happened. There's a guy in the room 13 months before this project who saw this detail and he said, Charlie, I've got 11 places in here where I have to abate. And those 11 spots, we're going to shut down work for 12 to 24 hours because of the cone of influence, the options that we have, or the chemical or sandblasting. So we recognized we had a problem. Now, we recognized that problem well in advance. And that allowed us to go do some research. The individual who came to me, those are his initials on this piece of steel. Because we recognized this well in advance, we were able to go out, research. At the time, there were only 4 of these in North America. So this is a laser abatement machine. There's fiber optics running to that head. It goes through paint, rust, oil, down to bare metal. Now, if I had not worked with DJ, had this opportunity 13 months out, and we've done our normal schedule review, and here I'm going to pause this for a second, see if I can go back a couple of slides. It's my first time trying to write like this. So normally, and this is how I developed this detail gap theory. So I'm going to go ahead and put that on here. Boy, I'm terrible on detail gap theory, right? So detail gap theory is that what I observed is about 2 weeks before the work, right? So when here, inside of 2 weeks, I started getting different answers as we would do schedule reviews. And so that became the question in my mind. How do I get the 2-week focus well in advance? Now, to get that laser abatement piece of equipment in, so we pulled a trigger out here, like at 13 months. So we had to go through contracts and approval and EH&S. We had to get it in the plant, and we had to test it in the plant. And we had some problems. We had a head go on, so then we had to get all these final approvals. What's happening? What do you see here? If I recognize this as a problem with DJ 2 weeks before the outage, ship sailed. There's no answer but to brute force through it. But if I recognize the problem early enough, now I've got this runway to go get better equipment and solve our problems. So with DJ, we really proved that detail gap theory. We had magic happen. Why? Well, so that abatement was 26 hours of critical path in 2012. We did that in 4 hours in 2014. 22 hours at $150,000 an hour on true critical path in the outage is a significant return. It's financial magic. It's almost too good to be true. But over and over, we found those almost too good to be true opportunities because we took the time and the effort. And what now I say is it's only 15 to 20% more effort if you have a model to build a 4D schedule than to build a traditional Gantt chart schedule. And if you use certain approaches, you can improve on that even better. So where does that leave us? Well, if we're practitioners and we're doing complex projects, whether outages or construction, we absolutely must disrupt or will be disrupted. Primavera disrupted Artemis. Primavera P3 was disrupted by Primavera P6. There are now efforts underway to disrupt that as a platform. And this is why, again, like I said, I'm tired of the conversation. Should we be doing 4D? Absolutely. Model, but model and understand both your model space and your construction or your project delivery time. So I'm going to come to the end here and have an opportunity for questions, but wanted to circle back. I also learned a lot from a project manager, and this is one of his bulls. We were at his house, and what you're not seeing is that there's a bed of a pickup truck, and there are 5 kids and 3 adults in the bed of the pickup truck. Skip's driving the truck. Another friend of mine's riding in the truck. I'm on the ground with another project manager, and then Skip's wife. And we were all feeding the bulls bread and the cows. And this bull decided to charge me. I'm not a cowboy. Didn't grow up around farm animals. But when I just instinctively reached down, grabbed that horn, I understood what take the bull by the horns means. This became a point of leverage. And that connected a little time later, this was before the 2014 outage, that 4D became a point of leverage and let us execute with certainty, make significant improvements. Now, there's another part to this story, and that is the little girl who's, growing. She was 3 and a half at the time of the San Francisco bike ride, or tricycle ride across the Golden Gate Bridge. She was now 8. And if you play this video back, you hear the adults yelling at me, "Hey, Charlie, get in the truck, get in the truck." Well, I'm not an idiot. I'd much rather be in the truck. Couldn't get there. There's one voice not saying something about getting in the truck. It's that 8-year-old little girl, and she's saying, "Tooey, tooey, tooey." See, she's yelling at the bull. And as I turn to get away from the bull, you see her hand come forward, and that's her hand, and that piece of bread lands in front of the bull's nose and distracts him, and I kind of walk casually away at a pretty brisk pace. Each of us has team members, project managers, supervisors, guys in the field on the wrench. We're responsible for them. And another lesson for me, and hopefully for all of us out of this, is we need to work to keep the twinkle in their eye. So we never know when that one person is what stands between us and this charging bull. And then there's a fun part of this to me as I went back and looked at this over and over again. I don't know if you see what my feet are doing here, but they're doing a crossover step. And I played soccer, and we did a lot of crossover step drills. And I used to like them because I was slower than a lot of the other guys, but I was fast because of my long legs at these crossover drills. And this to me is the importance of play. And in an outage environment, you mentioned play, and some people look at you funny, but that is what we've been able to do by bringing 4D into the room. We've been able to play. And just like I didn't fall on my tail here because I played a lot and had a crossover step that kicked in 20 years after I'd last done it. Our teams in the field don't play. They can say like Bobby, "We got this. We've been here before." So I've got one more drawing I'm going to do, and I'm going to talk about briefly as I do this drawing this guy Marshall McLuhan. Well, I realized from him they have different types of media. This is just going to take a couple minutes and maybe some time for questions. So what I've learned is on any project we have our as-is conditions. Okay, so maybe that's a greenfield where it's a new construction project, or maybe it's like what we deal with, which is a really complicated brownfield. We're going in and changing what's there. But we spend a lot of time documenting the as-is conditions. We do surveys, we do attempts to get at as-built. I think as-built are a fairy tale, which is why I say as-is. I'm a big fan now of going in and doing scanning. But we have all this work we do for our as-is conditions. And then on this side of the spectrum, we have our to be, our final state. And I especially emphasize this when I talk to guys who are heavy into BIM, because that's great. What is BIM? BIM is, that's the to be, that's the final state. So we talk about clash, we talk about the environmental impact, we talk about all sorts of technical features of the building or the product or whatever. For us, in the final to be thing, we're going to have an EC change that's going to impact how we operate certain things in the plant. Well, so I guess what I'm trying to communicate is we spend a tremendous effort here getting these as-is conditions documented well, and here making sure that at turnover, right, because that's really what all this leads to. So come down here and we have turnover. But in the middle, there's another gap. This is not the detail gap, but what happens here? We turn it over from the as-is conditions. We sign contracts. We bring in, crews. We do for us tag outs, whatever we do, and we do what's called construction. But we don't apply the same effort to construction that we applied in the as-is or in the to-be state. And often, unfortunately, what we end up with is chaos, which is why we don't understand priorities. We struggle with space. We have congestion. We have unfortunate and often tragic safety events. So this is a big word. Don't choke on it, but it makes a point. There's a word consilience. So consilience is unity of knowledge. And stop there and think about that word unity. When was the last time you were on a job site and what you would observe about that job site was unity? Not often, most likely. So consilience is this effort to, instead of having fragmented or siloed areas of expertise, is there a way that in this construction phase we can have consilience? We can have unity of knowledge. We can have a universal language, a common understanding of our problem. Absolutely. That platform is 4D. It's very important to us in outages. I trust for most of you it's already an important part of your projects, and we're simply going to improve how we deliver work with 4D. And if not, come on in, the water's fine, and hopefully we'll have good stories to tell together in the future. So, Sue, thanks for the opportunity. I always say I learn when I go through these. Reach out to me at any time, and I've got some time here if anybody has any questions.
Okay, Charlie, we can't thank you enough, and you can all see why Charlie's a favorite at industry conferences. He's an excellent presenter, and he puts it in a way that we all relate to and understand, so we appreciate you taking the time. We know how busy you are. So please submit questions in the question panel. We do have a couple questions here. The first one is, do you see this as a disruptive technology or a additive technology, Charlie?
All right, so we're in political season, and I will answer politically that depends on who's asking the question. For scheduling practice, I think it's absolutely disruptive. For BIM, I would argue that it is additive. The additive component is understanding schedule time in addition to the model space. For software vendors supporting the construction industry, it is, again, disruptive, and we need to recognize that. It can be complementary to good scheduling practice, but it is competitive in what your end goals are for that scheduling practice. The end goal is no longer to produce this enterprise, data product that sets you up to feed the accountants and the auditors and the lawyers. The end goal is to build a communication model that, whether on a projector or 3D PDF or video, or very soon, and for some people actually we're happening right now in the HoloLens, you're communicating to the guys in your field. And I didn't put this in here, but I didn't want this to become about the old school thinking, but part of the old school thinking is, how do we manage costs? Well, cost is a derivative. So this is a disruptive thought. You manage costs by supporting the guys that really move the needle on cost. That is the guys doing the work, how you plan and you produce the work. The downstream management of cost, the after the fact, the Marshall McLuhan rear view mirror type thinking, you don't truly manage your costs. You try to control and mitigate or lessen damage. So hope that helps. That's a great question.
Okay, next question is, could you talk a little bit about how your team embraced or reacted to the transition to the use of 4D?
Okay, so there was some resistance from engineering, to be quite honest. There was the questions, hey, do we really need this? But now we've circled out of that and have engineers making recommendations to other sites, hey, we should do this. There was resistance by some old school guys, we've always done it this way, but honestly broke through that because of that big kind of early failure on a couple of metrics. And then how we did it, we came into it because I had some experience with Synchro back as far as 2008, knowing visually what we wanted to communicate. So I say that before you even turn on the software, you need to start building a list from pictures, from walkdowns, from metrology scans, whatever you're doing. These are the parts of the projects we know we want to see visually and manage visually. So in P6 I put us up an activity code, and the code was to define what type of visualization we were going to do for that activity. So when we used the API to come into Synchro, we were ready. And then how we've used it, it'll be that talking point in the room where we put up on screen and we step back and forth and we go through problems and everything's there in Synchro, and we zoom in and out and we can see, what are we facing? This happened to me yesterday. We've got a pipe coming out of the bottom of a motor where you can really only fit a half a guy in that space. And the question was, do we have to take the flanges off the pipe, or can we go rotate it and keep the flanges on? And looking at that model, which was done from the metrology, the conclusion was the way that pipe is set up, we would be able to rotate it and save the removal, storage, and reinstall time on these flanges. So it becomes that weekly review, and then we've not done this yet, but we look forward to tracking items, doing resource model status and getting feedback on when actual deliverables are completed. I didn't speak to this today, but another big gap in the old school way of thinking, because the tools we had was we would build activities that are representations of the work. And what you come to appreciate about 4D is, instead of talking to status on representations of the work, you end up talking to status on the actual work itself. So you're much closer to the truth that way.
Okay, very good. Thank you. I don't see any other questions coming in, but as always, this session is recorded. Feel free to reach out to me if you have questions later on, and we hope to see you back for future webinars. But on behalf of Charlie and myself, thank you for joining us, and we appreciate your taking the time out of your day to join us on the webinar. Okay. So thanks, everybody. Thanks, Charlie. Any last words, Charlie?
Like I say, I love to talk about this stuff. If that didn't come across, call me anytime, and appreciate everybody taking the time to join us on the weekend.
All right, very good. All right, everybody enjoy your weekend, and we'll see you again soon. Bye-bye.